Have you ever really thought about sound? I mean, really thought about it? It's everywhere. It's the music you love, the voice of a friend, even the quiet hum of your fridge. But what is it? What is this invisible thing that shapes our world so much? Well, today, we're going on a journey to find out. We're going to break down the science of sound, all the way from a tiny little shake to the feeling you get in your brain.
So let's kick things off with a little mystery. Take a look at this. We've got a bell ringing inside a sealed glass jar. You can see it moving, you know it's working, but you can't hear a single thing. It's totally silent. So what's going on here? How is that even possible? Where did the sound go? This one puzzle, believe it or not, holds the key to everything we're about to explore.
To crack the case of the silent bell, we've got to tackle two huge questions. First off, what even is sound? And second, where does it come from in the first place? Answering these is going to take us on a pretty cool trip, starting with the source of every sound you've ever heard.
All right, let's start at the very beginning, the source. Every single sound, every single one, from a whisper to a rocket launch, starts in the exact same way. And the secret ingredient is something you can actually feel.
Think about a simple rubber band. You stretch it, you pluck it, and you get a sound, right? But if you look really close, you can see it's a total blur. It's shaking back and forth super fast. Well, that rapid back and forth movement has a name. Scientists call it a vibration.
And these vibrations aren't just tiny little movements. They pack a punch. Check this out. This is a tuning fork, and it's designed to vibrate perfectly. So you strike it, and then you dip it in water, and whoa! It literally sends water flying everywhere. That right there proves that a vibration is pure energy in motion.
So this is the first big takeaway. The fundamental rule of sound is this. Sound is produced by the vibration of objects. That's it. It's that simple. If something isn't vibrating, it's not making a sound. A guitar string, a drum, that tuning fork, it all starts with a vibration.
And you know what? This is happening inside your own body, right now. Go on, try this with me. Put your fingers gently on your throat and just hum for a second. You feel that buzz? Those are your vocal cords vibrating away to create the sound of your voice. Every word you say starts just like that. Okay, so every sound starts with a vibration. Got it? But that's only half the story, right? A vibrating guitar string is pretty useless if that vibration never actually gets to your ears. So the next question is, how does sound get from point A to point B? How does it travel?
Let's circle back to our mystery from the beginning. In this experiment, you can hear the buzzer inside the jar just fine. But watch what happens when a pump starts sucking all the air out. The sound gets quieter and quieter until, poof, it's completely gone. The buzzer is still going, but the sound has vanished. And that is the solution to our mystery. The jar with no air is basically a miniature version of outer space. It's the reason for that famous movie tagline, "In space, no one can hear you scream." That's not just for dramatic effect, it is 100% true. In the vacuum of space, just like in our empty jar, there's nothing for the sound to travel through.
This leads us to our second huge takeaway for today. Sound has to have something to travel through. Scientists call this a medium. You can think of sound like a messenger that needs a road to get from one place to another. If there's no road, no medium, that message isn't going anywhere. And that road isn't always air. Sound is an incredibly versatile traveler. Of course, we hear it through gases like air all day long, but it also zooms through liquids. That's how whales can talk to each other across huge parts of the ocean. And it travels through solids too, which is why you can easily hear a knock on the other side of a solid door.
So, sound travels through gases, liquids, and solids. But does it travel at the same speed through all of them? Is a whale's call traveling at the same speed as that knock on the door? The answer is a definite no, and it's actually pretty wild.
Just look at these differences. They are massive. In air, sound chugs along at about 347 meters per second, but in water, it's more than 4 times faster. And in a solid like aluminum, it's moving at a mind-blowing 6,423 meters per second. So why is that? Well, in solids, all the particles are packed super tightly together so they can pass that vibration along way more efficiently.
This brings us to a classic question, one you've probably wondered about during a storm. We all know that lightning and thunder happen at the exact same time. So, why do you always see the flash of lightning first, and then a few seconds later, you hear that big boom of thunder?
The answer is really simple. Light and sound are in a race, and it is not even a fair fight. Light travels at an almost unimaginable 300 million meters per second. It gets to your eyes pretty much instantly. But sound?
It's just meandering along at a mere 347 meters per second. It's like a supersonic jet racing against a bicycle. The thunder never even stood a chance.
Okay, so we've followed the journey of sound from its source as a vibration, and we've seen how it travels through a medium. But the trip isn't finished until it reaches its final stop, your ear. How does this invisible wave of energy turn into something your brain actually understands, like a voice or a song?
This really clever little experiment shows us exactly how it works. You've got a person speaking into a tube, and at the end there's a thin membrane stretched over it, kind of like a tiny drum skin. As the sound vibrations from their voice hit that membrane, they transfer enough energy to make those tiny seeds literally jump up and down.
Now here's the amazing part. Deep inside your ear, you have something that works exactly like that membrane. It's called your eardrum. When those sound vibrations traveling through the air finally reach your ear, they make your eardrum vibrate. And those vibrations get turned into signals that your brain can finally understand as sound. But our brains don't treat all sounds the same, do they? Why is a melody so beautiful, but the sound of a jackhammer is just awful? Well, it all comes down to the pattern of the vibration. Music is made of regular, organized, pleasant waves. Noise, on the other hand, is just chaos, a messy jumble of irregular, jarring vibrations.
So understanding the science is really cool, but it's also super important to think about how all this sound and noise affects our lives every single day. Let's zoom out and look at the big picture. When those irregular, unpleasant sounds, that noise, become constant, we get what's called noise pollution. It's all the unwanted, disturbing sound from things like heavy traffic, nonstop construction, and loud factories. And it doesn't just annoy us, it can actually harm our health.
But here's the good news. There are actually simple, effective things we can do about it. Making sure silencers on cars and bikes are working, not blasting loud horns, and even just planting more trees, which are amazing natural sound absorbers, can make a huge difference. And of course, being mindful of noise near places like hospitals and schools is just a really important, considerate thing to do.
And so our journey comes to an end. We've gone from a tiny vibration to a wave of energy traveling through the world to a complex signal inside our brains. We've figured out how sound works. And that leaves us with one last thought. The world of pleasing sound, music, nature, the voices of people we care about, it's a real gift. So the question for all of us is, how are we going to protect it?